All right, looking at problem number 3 in 5.2, it's our first definite integral I'm doing with you here, guys, out of homework here. Definite integral from -2 to 1. Notice we always read that from the lower limit of integration to the upper limit, so from bottom up. Let's remember that. You would not say this is the integral from 1 to -2. Definite integral from -2 to 1 of 3x plus 4 dx. Now, first thing I wanted to point out, the book has put parentheses around your integrand right here. Those are really unnecessary. You don't need them there at all because really the integral kind of tells you where this expression begins and the dx kind of tells you where it ends. So by default then, guys, everything between here and here, that's the function that you're integrating. So those things really aren't necessary. And I want to point out the directions, and I really hope everybody sees this here before we take the quiz over this section here, because the directions are important. It says in exercises 1 through 10, I'm reading directly from the book now, draw a graph of the signed area represented by the integral and compute it using geometry. So I want to remind everybody that what you probably learned at the very end of last year in pre-calc, and what we're going to be doing later on in this chapter, is that you generally are using a definite integral, there you go, for the purpose of computing the area underneath a curve. So for example, if you're looking at a curve like this and there's some crazy function that does this, and you want to come up with the area now between here and here, there's no geometric formula for finding that area. So you would use the definite integral in order to figure out what the area is. But what I want to remind everybody is that this arrow that I've drawn in the middle here is actually a two-sided arrow. And that if you know what you're doing, you can use area in order to figure out the value of a definite integral. And that's what they want us doing in this problem right here. You'll notice, at least I hope you will, that in all of these problems in 1 through 10, these are functions that are simple enough that you guys can graph them and use what you've learned about geometry to come up with the area. So what's happening here in this problem, guys? I'm going to draw a graph here. It's not going to take me too long. And we're going from -2 to +1. And we're dealing with a linear function now, 3x plus 4, which is roughly, I'm going to say there's my y-intercept of 4. A slope of 3, I would be right here if I'm doing this right. Yeah, and it would look something like this, guys. All right, so that's what you have here. And again, we're looking at a region here that starts at -2. So I'm actually going down until I hit the curve right there and ends at +1. So I'm going up right here. So what's going on here, guys? We've got one region right here below the x-axis and then a larger region here above the x-axis. So again, we're going to use area in order to figure out the value of the integral. Okay, first thing I want you to notice, it would appear to me that these two regions that I've shaded in red are not the same size. If they were, our answer here would be 0, because one of those regions is above and one of those regions is below the x-axis. But it looks to me like the larger region is up above, which makes me think my answer is probably going to be positive. Let's get working on this here, guys. So for, let me go to purple right here. All right. I'm going to get working on this guy here. Area of a triangle here is 1/2 times our base times our height. So what is that going to do for us? I'm pretty sure that that x-intercept right there looks like it's at -1.5. It wouldn't be a terrible idea to take the function 3x plus 4. Oh, yeah, no, I think I was wrong about that. Hang on a second. Set it equal to 0 and solve. So 3x is equal to a -4. Yeah, I'm glad I checked. X is equal to a -4/3. So that's where we are right there, not the -1.5 that I had thought. So for this first triangle, our base then goes from -4/3 or -1 1/3 to +1. All right, that's going to be what, guys? 4/3 right there, plus another 3/3. Our base there of that triangle is going to be 7/3. And the height of it is going to be measured right over here. So all I'm going to do, guys, is evaluate this function, 3x plus 4, at x equals 1. So right there, I'm just going to write f of 1 is equal to 3 times 1 is 3, plus 4 is 7. And that is the height of that first triangle. This didn't work out that nicely. 7 times 7 is going to be a 49 and a 6 on the bottom. Gotcha. Yeah, that's it. That's the area of that triangle up on top. Now what we also have to do, though, is find the area of the triangle down here on the bottom. So again, area of a triangle is 1/2 times its base times its height. So that's going to be 1/2 times a base right here from -2 to -4/3. That's a base with a length of 2/3. And the height of that function comes from evaluating this function right here at -2. So f of -2, again, going back to the original function here, 3 times -2 is -6, plus 4 is -2. Now, you can approach this in one of two different ways. I would imagine that most of you guys would say, hey, height can't be negative and neither can area, so I'm just going to put a +2 there. Now, that's okay. That's a good way to look at it, but you're going to notice I'm going to have to do something interesting in just a moment, so hold that thought. Here, the 2 on the top, the 2 on the bottom cancel each other out, and we end up with just, yeah, that's it, just 2/3. For the area of that second triangle. And I'm going to go ahead and convert that to a 4/6 just so that these two fractions have a common denominator. And now, everybody, let's put it all together. Remember, the question is asking us not to find area, but up here at the top, to find the value of a definite integral. So what I'm going to do is take the positive area of any region that's above the x-axis, which is this one right here. So I'm going to start off with a 49/6. And then we're going to subtract the area of any region that's below the x-axis, which came out to be 4/6 right there. So I'm going to go with a -4/6, and that's going to get us 45/6. At a bare minimum, I would divide out a 3 from each side there and get a 15/2. And then at that point, if it wasn't too much trouble, I'd probably rewrite that just because I like to as 7.5 or 7.5. I'm going to circle that, and that should be my final answer to problem number 3 here. I was expecting an answer that was positive because region number 1 up here above the x-axis looked quite a bit larger than region number 2, which was below the x-axis. Now, the other thing you could have done, guys, is you could have said, okay, the height of that second triangle is -2. You could have put a negative right there, which would have made this answer negative, and in that case, you've already considered the negative. Now you just add these two results. So it would have been 49/6 plus a -4/6. And of course, you end up with the exact same answer of 45/6 or 15/2 or 7.5. So I'm kind of a fan of what we did up here at the top. All right, make those areas positive, but then you guys just consider whether it's above or below the x-axis. And if it's above, you take the positive version of that, and if it's below, you just subtract that away from your answer. But any way you do it here, the value of this definite integral is 7.5 or 15/2 or 7.5.